are going to be talking about how water moves through Earth's materials. We're also going to discuss the nitrogen cycle. We talked about the water cycle. We're going to talk about how the nitrogen cycle plays a part in that. And then we're going to look at the river of life, because that is water, obviously. So you should have a sheet like this in front of you that says water movement through Earth's materials. And we're going to do a little bit of a demonstration. On your paper, it tells you to draw the particles that you see. So what's going to happen is, in a moment, on the screen here, where you see the document cam, you are going to see some particles that we're going to be dealing with: sand, gravel, and clay. And you are going to draw those particles how you see them on the document cam. Any questions so far? Okay. After that, we're going to predict how fast the water will flow through those particles: slow, medium, or fast. Okay? In relation to each other. Will sand be faster than gravel? Will it be slow? Stuff like that. Slow, medium, or fast. Then we're going to watch the water permeate through each particle. And then we're going to write down the actual rate. Was it fast? Was it slow? Or was it medium? And then we're going to answer these questions. Any questions about what it is that we are doing? Shall I turn the lights off more for you to see?
Yes.
Okay. Hit the lights a little bit more, Yael, please. You can see there, okay? All right, good. So, the first one we're going to deal with is sand. And I'm going to take a half a teaspoon of sand. Actually, I think I can take a full teaspoon. Not half. I'll do a half. And when I say we're looking at the particles of the sand, I'm going to just spread them out a little. Because we can see they're small granular particles, and if we were actually drawing the particles of sand and we see them, they're not tightly packed together, are they? No. So we can draw them. Yeah. Like so. I know how much you guys love putting dots on your papers.
That's your hobby of mine.
I figured. Okay. The next one that we're going to look at is gravel. And again, I'm going to take a half a teaspoon of the gravel. And when we look at the gravel, then we can draw that how? Larger particles. So they're not dots anymore. They're more like rocks. Some are bigger than others. Some are larger than others. Okay? So now let's take a look at clay. And this is dry clay, not clay that's already been moistened and molded. Again, I'll take a half a teaspoon. Why am I being consistent with the amount?
That because it would be more or less permeable depending on the amount.
So why am I being more consistent with the amount of each? So it's fair. Good. And if we look at those particles, they are tightly packed together. So you hardly see any spaces. Make sure when you're putting your dots on, as you can see mine, I'm not putting them so close together that it looks like just a circle. I'm not putting them together where it just looks like this, because then it'll look like one particle. But I'm putting them close enough together that we see that they are particles, but they're still tightly packed together. Sand are particles, but they're not as tightly packed together, okay? Now, let's take a ranking, a predicted rank. How fast do we think that the water is going to flow through sand? Slow, medium, or fast?
Medium.
Do we all agree with medium?
Yeah.
Okay. What about gravel? And what about clay? Now, raise your hand. What helped you determine these rankings of speed? Nick.
Experience.
Okay, that's good. What else? How far apart? What are? You're done with it. You're done with the slides. How far apart? The particles are. Okay.
The size of the part.
The size of the particles.
It's like porous or something like that.
Okay, porous. How many? That means the space. How far apart they are. Now, let me ask you this: when we talk about the water moving through the particles, what are we talking about? What's that moving through? The ability to pass through. What is that called?
Permeability.
Permeability. So that's why I use the word watch as the water permeates through the material. So let's start off with sand. And I just placed it in a container here where there is, as you can see, there's a container at the bottom. These are just salt shakers. So I took the top of the salt shaker, turned it upside down. As you can see, there's holes. Can you all see that on the screen?
Yeah.
But there's holes in the salt shaker. I placed the filter with the sand on it in top. And I'm just using the filter so that the salt doesn't fall through the little holes on the salt shaker. And then we're going to take a look at how fast or slow or medium it flows through. I'm going to back this up a little bit. Yeah, I just have to do it kind of slow or else it'll blur out. It's kind of blurry now. Okay, all right, so I'm just going to take a half of this container, half of water there. I don't remember which one this was because I changed the shape every class. All right, and I'm going to slowly pour it. And I'm actually only going to use a half of that, a half of this. I won't take it to the line because that's too much. But if we looked at it, the water did drip down to the bottom, but was it instantaneously or was it more like a dripping process? It's more like a dripping. It wasn't like a pouring, correct? All right, so would that be slow, medium, or fast?
Medium.
That would be medium, so we were right with that. All right, let's look at the gravel. Bless you. And again, I'm taking only a half of this. Why am I being consistent again? So that it's fair. Was that dripping or pouring?
Pouring.
So would that be slow, medium, or fast? Fast. Too fast, too furious.
Was it 6 months on that?
Yeah.
Is it?
Yeah. And then like take down a gang.
Vin Diesel's gonna be in there too?
Yeah.
And the rocks.
And oh, I did see the previews of that. Okay, here's the clay.
They're gonna be on the same team.
I've already seen it. They died. Both of them. Sorry, yeah, no.
Spoiler alert. Okay, so here's the clay.
Okay, hey, the water drop.
Clay absorbing.
Hey,
water.
There's no water. The clay is open.
No water. So this would be considered slow or almost none. But very, very, very slow. But there's the water. It's a little bit dropped. See that down there? So slow, medium, or fast? Slow.
It's infiltrating the flow.
Good. Which sample was more permeable to water? Raise your hand.
The gravel.
Gravel. Which was the least permeable? Clay. Now, why did the water move fast through some materials than other? La Lomano, raise your hand. Maya. So what are you saying when you say they were packed together? The particles were? They were smaller, but the particles were closer together. Not absorbent, the particles were closer together. So it depended on the amount of space between particles. The larger the particles, the more or the less space? The more space. The smaller the particles, the less space, which fed off of your homework that you had the other day in answering those questions. What was the aquatard? Raise your hand. The aquatard in this demo. Clay. Why would we say clay was the aquatard in this demo? Chandler.
Because it slowed down the water running through the fastest. Or it slowed it down the best.
It slowed it down the best. It was much more slower than all of the others. So it almost stopped it. Now, last question. How would an aquatard in this demo affect agriculture or wells? Yeah. Exactly. So she says for the wells, they would basically be dry. Who wants a dry well?
Me.
I mean, you wouldn't be able to take showers. Oh, wait, you don't take showers. You wouldn't be able to drink water.
I don't drink water. I drink Coke.
Okay, well, they need water to make soda.
Okay, then I drink Coke.
And then she said, with the agricultures, inappropriate. With the agriculture, she said that the plants would not grow. I'm going to put grow and then put an X through it. And what about in agriculture? The only thing we grow are plants?
No.
What else do we grow in agriculture?
Trees, food.
Food, your crops. There would be no crops. Which means when you go to Harris Teeter or any other grocery store you may shop at, Walmart, you go there, your parents will go there looking for your fruits and your veggies, and they'll say, sorry. Because if the land was filled with an aquatard, then they would not be able to grow crops to sell to the grocery stores.
Wouldn't like herbivores die off too if there was no plants?
Exactly. It would affect all around. Animals or species that only eat plants would begin to die off. Very good. Very, very good. Any questions about this? Okay, good. So now that you had a demonstration to see how that actually works, to kind of put it into perspective for you, instead of just answering your questions, now you can actually see it. If you look at your next page that you have in front of you called the nitrogen cycle, we are going to show the nitrogen cycle. Now, I am going to put on the board different colors so that we can use different colors. And we're just going to use this marker, and what you have to do is just pick the color that you're going to use. We're going to have some volunteers come to the board, and I'm going to tell you what it is that you're going to draw when you come to the board. I won't tell you until you get up here. All right? Good? And as we're drawing it, you're going to also draw it. I need a volunteer. Come on, Josh. Josh. Josh, can you please draw us some clouds? Notice my background is blue, so this is the landscape. Give us some clouds, Josh.
Clouds are white.
I'll put on it.
You can give us 1, 2,
Alright.
Kalamazoo.
That's good. Thank you. All right, another volunteer. Come on, Timo.
Dang it. Oh, did we draw the question? Oh,
Timo, can you give us some underground dirt?
Underground dirt.
We need some dirt so that we can get ready to grow some grass. Do you need a different kind of brown? We could give you more brown.
Ooh, now you can fish it for the brown.
That's it, okay.
It's beautiful.
It's wonderful. This works. Just don't put, yeah, make sure we don't want it.
What do we do with the line under that part of the...
That just stops where your picture stops. So let that be the very, very, yeah, don't go below that one. Okay,
Nice dirty.
good. May I please have another volunteer? Maya. Maya, now that we have our dirt, can we get some grass?
Add variation in color.
Depending on if you want it. No, you don't have to color if you don't want, but if you want to color it, that's perfectly fine, you can.
I color all my pictures.
So you get to stay in the lines, okay, honey?
4-year-old?
All right,
You got
can I
this one?
please have another volunteer? Come on, Danny.
No.
Danny.
All right, Danny, can we please get some plants?
What's that? Sound like a brown flower?
No, that's red. You know what brown?
That's red.
Oh, let's get you
That
brown.
looks like a poop brown.
Is that a tree?
It's gonna be a tree.
Oh, okay. Well, you can go ahead and draw a tree. Wait. I'm sorry. Hold on a second. Let's draw your tree over here.
Okay.
Let's put your tree over here. Give us some room. Bigger tree than that. That's like a little a newborn tree. Danny just drew us a newborn tree. Right here. It's a newborn tree. Wait, Danny. No, I don't want the tree over there.
Tree.
I know. We gotta put it over there.
Oh, okay.
Yeah, I didn't know trees were the height of grass.
All right. Let's give us another tree over here. Like a bigger tree. There we go. All right. I'm gonna add some leaves to this tree. Give us a bigger tree. Let this tree flourish.
Mutated tree, I'll tell you what. What? What the heck is that? Leaves.
I'm giving this tree some leaves. Yeah.
It's like, it looks like
Special classes.
why does that look like?
We give it some more leaves. So we got a nice looking tree here. Right? It's nice. Danny and I made a nice tree. Okay. I need un otro voluntario. Another volunteer.
Oh, right here. Right here.
Come on, Yael. I've got one girl so far. I need another girl. All right, Yael. I need, in this nice little area that we have here, lots of times we cut down trees in areas and we build homes. But that area really belongs to a Animal. What are the animals that we often see? That come deer. I need you to draw us a deer. And this deer will be munching on the grass.
You give everybody like trees and dirt and I know
Because
deer.
I figured the ladies can draw something
I can't
like that.
draw.
Strawberry. Penguins.
That's the best that we can. Just make sure you give it some legs, a body, and a face.
I draw birds. A
Oh,
giraffe.
it's gonna be bad. Oh god.
It's turning out wonderful already.
Just be honest, if you just said a giraffe to eat the tree.
That's actually good.
Turning out wonderful.
Looks like a camel.
Yeah, it's turning out absolutely gorgeous. It is one, oh my goodness, this is a phenomenal deer.
Only reason why I was shooting that, I'm just going to inspect the leg.
I just want to know what the back part of it is, but this is a wonderful deer. Oh, it's a headless deer! Or, where's the head?
You gotta be kidding.
This is wonderful.
Got a butt face. Dude, the head's inside of his torso.
Keep on going. Yeah, where's the front of the deer?
There.
That was in the antlers.
Oh, this is wonderful. Oh, the head's on Taylor's wall. Oh, that is a phenomenal deer. Let's give Gael a round of applause.
Oh yeah, he needs another
He only has one
He
antler.
can be like Elliot.
I said a deer, not a reindeer. No. All right. Remember, deers eat what? Okay, so let the deer have some grass hanging out of his mouth. He was just feeding on grass. All right, so far, we have our landscape here. Give everyone a round of applause that helped out with our landscape. All right, now if you look here, it says, okay, guys, that nitrogen is the most abundant element in our planet. A lot of us thought it was oxygen when we talked about elements, but we clearly figured out very soon that it was not oxygen. And approximately 78% of the atmosphere is comprised of this important element. So in addition to the water cycle where water flows through, we also have a carbon cycle where carbon flows through because carbon is also an element that is in organisms. Then we have the nitrogen cycle. And what happens is, let's start from the very beginning part, when plants and animals die, so when this poor deer dies, unfortunately, nitrogen will go under the ground. So once it dies, it will decay. And then what will happen?
The sky turkeys will come and eat it.
Well, first this animal will decay, and it will follow the same cycle as the water does, where it does what?
No,
It
it percolates.
infiltrates and percolates. And what will infiltrate and percolate down into the earth is nitrogen. Well, that's fine too. I'm talking about when it does. But even when it ends up in your stomach, you're breathing out nitrogen. So you're still part of the nitrogen. So, yes.
I thought we were bringing out carbon dioxide.
We breathe out carbon dioxide as well. So nitrogen in, guys, you need to be writing this. Nitrogen in decaying matter and waste. This is how it gets down in the ground. And this is from plants and animals. So even with the plants. Yes. Your bacteria from the decaying matter, because remember we found out that bacteria is in our ground because of the decaying matter, it turns it into fixed nitrogen. And then this is used, God bless you, for plants. And then this is going to go back up into the plants. So decaying matter breaks down, gets into the ground. That bacteria for decaying matter is turned into fixed nitrogen, which is then used for the plants. So it goes up to the plants. Then your nitrogen in your plants nitrogen is in plants for protein, but then your plants are going to then release nitrogen in the air. Not only do they release it into the air, but when your animals eat the plants, they also take in nitrogen because the nitrogen was released from the ground back into the plants. Your animals are going to take the nitrogen in from the plants because they eat it. So far, animals take it in from the plants. They pass away. It gets back into the ground. It comes out. It goes into the plants. The plants then release it into the air. But also, the animals release it into the air because of they're taking in plants. They're also releasing, when they breathe out, they're releasing nitrogen.
And when they poop it out.
That too.
Very cool.
And then once it's in the atmosphere, in our clouds, it rains, it hails, it snows, all of that stuff. It's releasing it back into the atmosphere. And there's your nitrogen cycle. Any questions so far? Bacteria fix nitrogen used for plants. Used for plants. Now there are some benefits and there's some harms to this. Everyone have the picture? Everyone's good?
No.
We release nitrogen as well. So even though I have an animal here, this could pretty well be a human, a person, because we breathe out nitrogen because we take it in when we eat what? Plants and animals.
Say like people that are having a fire in their house and it goes out of the chimney, is that nitrogen and just like dry smoke?
It's going to be carbon, and it's going to be a bunch of stuff depending on what's burning. But that's where we get pollution in the air as well. All right? So there are some benefits to this. What's the element symbol for nitrogen?
And
No, just N. And phosphorus, what's the element symbol for phosphorus? P. These things promote plant growth. So that's a good benefit. We want our plants to grow, whether it's for our gardens or for our agriculture, for us to grow food to eat. But we want our plants to grow because we need plants for what? Not just eat. Oxygen. We need plants for oxygen, so do animals. Nitrogen and phosphorus provide fertilization. And its compound produces bacteria. Which, remember, we have good bacteria and we have bad bacteria. I should say compound produced, sorry guys, by bacterial waste. So nitrogen and phosphorus provide fertilizers, and its compounds are produced by bacterial waste. What are some bacterial waste? When we looked at the picture, what are the waste? What happens? The animal dies. So dead organisms. Organisms being animals and plants. And humans, but normally we don't die and put our bodies on the ground and just decompose. We go in a pine box.
What if you're in the woods and you're just strolling along and then boom, heart attack, dead. No one's gonna find you.
Okay. I'm a little bit more happier today. Yo soy feliz. I'm very happy.
Just give it to us.
All right.
Your wife again.
Here are the harms, leading into the harms, since we were so down and out now. We'll talk about the harms here. All right. So some of the harms here is because the nitrogen goes into the air and you have dead animals, too much of that, it can produce acid rain. And this is produced when rain, I don't know about this, is mixed with sulfur. What's the element symbol for sulfur? S.
Banging these up, Colin.
Or nitrogen.
And
So even though we need the nitrogen in the air, thank you, Chandler, when rain is mixed with sulfur or nitrogen, it gives us acid rain. And acid rain will destroy bodies of water, agriculture, and what else can it destroy?
Human.
Organisms. Good.
acid rain like tears down.
It sure can, depending on the amount of it.
Can you drink it?
No, you should not.
Yeah, you can have to drink acid.
Any questions about the benefits or the harms of nitrogen flowing through our nitrogen cycle? Okay, if you flip your papers over to the back, you'll notice that you have a paper that looks like this called the River of Life. We are going to watch a short video about the River of Life, and while you're watching that, you are going to answer the questions. Notice the first part is true or false. The next part are questions. It tells you that you do not need to write them in a complete sentence because you won't have time as you're watching the video. In addition to watching the video, I want you to jot down some more interesting facts that you learn about our rivers and our world. If you are listening to this lesson online, then you need to look at my website for the link for this video.